new topic called as the signal flow graph, and it is also called as the Mason's gain formula. So this is similar to what we have done in the block diagram reduction rules, but there are some advantages with respect to when I this signal flow graph with the reduction rules. There are some benefits. Like one drawback of the reduction rules to reduction rule approach to get the transfer function of the system is like every time we have to redraw the block diagrams after every step. So this will be a time consuming, and instead of that, a new approach called as a signal flow graph approach was introduced. So it has one direct formula, and using that formula I can get the transfer functions very easily for any kind of a complex circuits. So this formula was stated by Mason's, so hence it is referred as a Mason's gain formula. Okay, so it will be something like this. We call it as signal flow graph. It can be abbreviated as SFP, SFG, and also it is called as or Mason's gain formula. Gain formula. Okay, so it is also referred as Mason's gain formula, and the formula is something like this. We call TF, that is transfer function, is equal to summation of T K into delta K. We'll try to understand what this Tk and delta K are, and divided by it is a delta. Okay, so this is the formula that we will be using, and here K implies number of forward paths. And Tk refers to the gain of the kth forward path. We will try to understand what this forward path in a later stage. This is a gain of a kth forward path, and delta is equal to system determinant that has to be calculated as below. Like I'll try to write that in next this one. or I'll try to accommodate here. Delta is equal to 1 minus summation of all individual feedback loop. Okay, so I will write just gain, loop gain. Okay, plus, so here it is minus and here it is plus, into summation of all the gains into gain product. I'll just write the short form. I'll write just product of all possible combination of, I'll just write a combination of two non-touching loops minus, you see here it is first minus here, then plus, again it is a minus, into summation of a gain of a three non-touching loops. So I'm shortcutting this. Instead of writing whole of this combination, like a gain product of all possible combination of three non-touching. So instead I'm just writing a gain of three non-touching loops, so that I can accommodate in a single slide. Okay. Now we will try to understand what is this transfer function. Already we know it is a ratio of a output to the input, and this k here, summation means summing up of all the loops. Summation of tk, k refers to the number of forward path. I will explain what this forward path is. And tk refers to the gain of the forward path, kth forward path, and delta k is the kth forward path determinant, and this delta alone is a system determinant that has to be calculated, and that is given by this. Delta is equal to 1 minus summation of all individual feedback loop gains plus summation of summation gain into gain product of all possible combination of two non-touching. Okay, you remember this, two non-touching loops minus gain, a summation of gain into gain product product of all possible three non-touching loops. Okay, so you remember these terminologies. I will be explaining about this terminologies in the next slide. Okay, so I'll take off this part now. Now let me draw one simple signal flow graph, and we'll try to understand what are those forward paths, and what is the loop, and what are the two non-touching loops, and what are the three non-touching loops. Okay, so let us take an example of this one. So here these are called as the nodes. So I'll just first mark the nodes. Let me do with a different color. Okay. So now I will name this node 1, node 2, node 3, node 4, node 5, node 6, node 7. And this is a flow of the signal. So I'll also write this as this will have some gain value. So I'll write it as a 1. Like I used to write the G1 and all, right? So this signal carries some value whose gain is 1. So I'll write those things, and this I call it as a G1. This I will call it as a G2. These are the gains, and that we used to represent as a blocks in a previous class, right? G4, and here it is 1. So these arrow mark indicate the flow of the signal. Now from 3 to 5 there is another loop. 3 to 5 there is another loop, and it is having a signal in a reverse direction. So indicating the arrows or the flow of the signal is very important here. So this I call it as a feedback as a H2 minus H2. And also similarly there is a feedback that goes from 6 back to 4. So again it is in a reverse direction, and it has a value of a minus H1. Also there is a one feedback that goes from 6 to 2. So this is another feedback, and whose value is minus 1. Now here what I have done, I have represented the signal flow graphs, which consist of the circular things are called as the nodes, and the arrow marks will show the flow of the signal from one node to another node. And these signals have a certain values which we call it as gains. So from 1 to node 2 there is a signal whose value or whose gain is 1. From 2 to 3 the gain is G1. From 3 to 4 the gain is Z2. 4 to 5 Z3. 5 to 6 G4, and 6 to 7 again is 1. And also there are 3 feedbacks, wherein from 5 to 3 it is minus H1, from 6 to 4 it is minus H1, and from 6 to 2 it is minus 1. Okay, now you recall the things that I referred in the formula. There was something called as a forward path. Now I have to identify how many forward paths are there. Forward path means it should go in a one single direction. There should not be a reversal of the signal. That we call it as a forward path. Okay. Now I will draw the forward path for this loop. I will say node 1, from node 1 to node 2 the signal is going in a forward path. From 2 to 3 there is a forward path. From 3 to 4 there is a forward path. 4 to 5, 5 to 6, 6, 7. So the signal is going only in a one direction, and that is in a forward path. Okay. So they are also having some gains. 1, let me represent as a different color. G1, G2, G3, G4, and it is 1. Following this, Any queries till now? Hello? Hello?
No, sir.
Okay. Now, how many paths, forward paths are there? I will write forward path is 1. I will say FP is equal to 1. There is only one forward path. Okay, are there any forward paths? Like if I take from 1 to 2, so 2 to 3, 3 to 4, 4 to 5, 5 to 6, and there is no loops that are going in from left to right. So all others are going from right to left. So that cannot be considered as a forward path. Always the signal should go for flow from left to a right. That I call it as a forward path. Okay, and if it is flowing from right to left, it is called as a feedback or a backward path. So I'm not interested in the backward path. I'm interested in a forward path. So in this signal flow diagram, there is one forward path. So in the sense, K is equal to 1, right? So I was referring, K is a number of a forward path. So I have only one forward path now. Now, the second thing, if you recall, I told that what is a loop? Loop in the sense the signal should start from one point and come back to the same point. That we call it as a loop. Now, let us identify how many loops are there in this. Okay, so I will say this, I will say a T1 because T is a forward path and K is only one forward path is there. So I will represent that as a T1. T refers to forward path and which path it is, K, that is K refers to 1. So it is a first forward path. And now let me go for a loops. So I'll say L1. So let me start with a 1. So 1, it will go to the 2, but there is no signal that flows back to 1. So I cannot consider that as a loop. But if I take the loop from 2, okay, the signal that flows from 2 to 3, there is a flow continuation. From 3 to 4, there is a flow. 4 to 5, there is a flow. And 5 to 6, there is a flow. And from 6 back to a 2, again there is a backward path, and this forms a loop 1. So let me draw it. So there is a 2, then 3, 4, 5, 6, and 7. So I will number it as from 2, 3, 4, 5, 6. Again the signal is going back to 2. So I can take this as a loop. So this will be a -1, and this is G1, G2, G3. Okay. Now, can you identify the loop 2? Can anyone tell the loop 2? I expect the answer from you people.
4 to 5, 5 to 6, and 6 to 4.
4 to 5, 5 to 6, 6 to 4. Very good. So I can take that as another loop. So I will start with the 4, 5, 6. Oh, sorry, 6. Then go back to 4. So this is 4. This is 5. This is 6. The signal flow is this, and the gains are, don't forget to write the gains. I will tell you the importance of writing these gains. G4. Okay. Can anyone identify the third loop? Yes, third loop. Yes, anyone?
So 3 to 4, 4 to 6, and back to 3.
3 to 4, 4 to 5.
5 and 5 back to 3.
Okay, very good. So I'll write.
Sir, at second loop, sir, feedback minus H1 is.
Yes. So I'll write it as minus H1. Very good. So 3 to 4, 4 to 5, 5 to back 3. Okay. So this I call it as minus H2 and 3, 4, 5. Let me represent the arrows. And this one is Z2 and Z3. Okay. You understood the concept of forward path and loops? Any doubts in representing these things? Hello? Anybody having a doubts in writing the forward path and the loops?
No, sir.
Okay. So you are
No,
clear
sir.
with how to write the forward path and the loops. Okay. So if I refer back, let me take the snapshot of this one. I will take off this. Before that, you take the note of this. Now I will write what is the value of this forward path. So all these are in a series. All the gains are in a series, right? In the sense, I can multiply all these things. So 1 into G1 into G2 into Z3 into G4 into 1. So the product of this can be written as G1, G2, G3 and G4. Just take a note of it. And here, this is again in a loop. So I can write the product of all this as, so since minus 1 is there, I will write it as minus G1, Z2, Z3 and Z4. G1, G2, G3, G4. Okay, this is for loop 1. For loop 2, minus H1, G3 and G4. For loop 3, minus H2, Z2 into G3. Just a product of this one. And if you see in the formula, what I have written, it was written as delta is equal to 1 minus the loops, individual loops, minus individual loops, plus the gains, the product gains of two non-touching loops. Now I have to understand this touching loops. Now in this loops, there are 3 loops here, right? In this signal flow graph. Now I have to check whether there are a pair of 2 loops that are not touching, Now let us see loop 1 and loop 2. I have to check whether they are touching or they are not touching. Suppose loop 1 is having 2, 3, 4, 5, 6 and loop 2 has 4, 5, 6. In the sense, loop 1 is touching to loop 2, right? Someone has switched on the mic. Can you switch off this? So if I see loop 1 and loop 2, so loop 1 is touching to the loop 2 at three regions, that is at a 4, 5 and 6. So I cannot have this as a pair because touching, and there should be two loops. Now let me check loop 1 and loop 3. Again, loop 1 is touching loop 3 at 3, 4 and 5. So here also there is 3, 4, 5, and here also there is 3, 4, 5. In the sense, even L1 is touching to the L3. I cannot take a pair of that. Now let me check L2 and L3. L2 is touching L3 at 4 and 5. Hence, I don't have the non-touching loops. Two non-touching loops are not there. So obviously, if two non-touching loops are there, are not there, the three non-touching loops will also not exist. Okay, so let me take off this and write the formula. So what was the formula? Formula was T F, that is transfer function, is equal to Tk into delta K divided by delta summation. Now, how many forward loops are there? Forward paths are there in this? Can anyone tell? How many forward
One.
paths?
One.
One. So in the sense, I will write T1 delta 1 divided by delta. If I have two paths, it will be plus T2 delta 2 by delta. So similarly, how many forward paths will be there? So many, the terms will be adding up. Now let me calculate the transfer function for this thing. Now, what was the value of T1? I have written a product of this, right? I have written, I told you to make a note of that. So what it was? Can anyone tell me what was the product of forward path?
G1, G2, G3, G4.
So I will write it as G1, Z2, G3, G4. Now I got this term. Now I have to calculate the delta. So let me calculate delta here. Delta was what? 1 minus, if you remember the formula, it is sum of individual loops. So how many loops were there? Yes, can anyone tell how many loops were there in my signal flow graph?
3.
So those were L1 plus L2 plus L3, and plus, are there two non-touching loops in my signal flow graph?
No, sir.
No, right? So in the sense, this term becomes 0. And also, I don't have three non-touching loops also. So this is also 0. Now, if I substitute this, delta is equal to 1 minus, okay, what was loop 1? I want somebody to tell.
Minus
Yes.
G1, G2, G4.
Minus G1, G2, G4.
G3,
Sure, right?
G.
Just check it, check it.
Sir, minus G1, G2, G3, G4.
Okay, so I'll write minus G1, G2, G3, G4. Agree? What was the value of L2? Loop 2?
minus H1 G3 G4.
Minus H1 G3
G4.
okay. Loop 3
Minus H2 G2 G3.
minus H2 Z2 C3, right? Okay. Now if I take this determinant is equal to 1, so I'll take all the minus sign common and it will be positive here, and this will G1 G2 G3 G4 plus H1 G3 G4 plus H2 G3, oh sorry, Z2. Okay, you can adjust it. Fine. So this becomes a determinant. Now I have found what is T1, what is delta. Now I have to find what is this delta 1. Okay, so delta 1 is 1 minus, so here what I have to check is the things here. Let me give an example. The determinant is already there, and from the determinant I have to derive this delta 1. So it will be 1 minus L1 plus L2 plus L3. So this is the delta. Out of this delta I have to get a delta 1. Now to do delta 1, there is a rule I have to follow. In the sense, I have to eliminate the loops that are touching to the forward path. Okay. Now you refer L1, just check whether it is touching the forward path. See the diagram and tell me whether L1 is touching the, what was the forward path? The nodes were this, right? Let me put here forward path. There was 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Just check this L1 loop 1 is touching this forward path. If any of the number are repeated in the loop, can anyone check and tell me? Hello?
Sir, not getting, sir.
Okay, 1 second. So you have to refer this diagram. So it will be overlap. I think I don't know how. I have to remove this. Okay, let me first write it and then I will explain it, because this L1 will be a 0. I'll tell why I am taking it as a 0, because if I want to remove it, it will go off. Plus 0 is equal to delta 1 is equal to 1. Now you have got all the T1, delta 1 and delta, right? From this delta 1 is 1. I'll tell you how I have arrived for this delta 1. Okay. Okay. Now so can you refer this? So I have created forward path, 3 loops and 3 loops, right? Now to get delta 1, to get this delta 1, I told 1 minus L1 was there plus L2 plus L3 was there. Okay. Now to get this delta 1, I have to eliminate the loop in this equation which is touching the forward path. I have to check whether loop 1 is touching the forward path. Can you see this T1 and L1? T1 is a forward path, right? And L1 is the loop. Check whether this loop is touching forward path. Where it is touching? Where this loop 1 is touching the forward path? So it is touching at the 2, right? This point and this point is occurring in both the things. It is there in a forward path as well as in a loop 1. In the sense, loop 1 is touching the forward path. So then I have to take that as a 0 if it is touching. If it is not touching, I should take the value of L1. Now you tell me whether loop 1 is touching a T1 or not. I want answer from your side. Hello?
Yes, sir. Yes, sir.
Loop 1 is touching T1.
Yes, sir.
So if it is touching, I have to take it as a 0. So that's the reason I have taken a L1 as 0. Now you tell me whether L2 is touching a T1.
Yes, sir.
Yes,
It
sir.
is
At
touching. Okay. So it is touching at 4 and 5 and 6. So I will take it as 0. Now L3. Tell me where it is touching. Just I have to see this 3 loop and T1 loop, T1 forward path. If the numbers are repeated, it means that it is touching. Even it is touching at a single point, it means that it is touching. There is no hard and fast rule that it should touch all the points. Okay. So L3 is touching at a 3 here and 3 here. So in the sense, L3 is also 0. Now you got what, why I have taken delta 1 is equal to 1 minus L1 equal to 0 and L3 is equal to 0. Clear?
yes, sir.
Okay. So I'll go back. I'll go back to this. So now you have to tell me what are the things. Like I have to calculate transfer function is equal to, so T1 into delta 1 divided by delta. So that is equal to transfer function. I can write it here as, okay. Tell me the value of a T1. What was the value of T1?
G1, G2,
Just now,
G3, G4.
whether it was carrying negative or positive, right? All were positive, right?
Yes.
G2, right? G2,
No, sir.
G3,
G1, G2, G3, G4.
G1, G2, G3, and G4, right? Okay.
Yes, sir.
So this is T1. What was delta 1?
1.
1. What was delta?
1 minus L1 plus L2 plus L3, L4. No, sir.
Ah,
1 plus G1 plus G1, G2, G3, G4.
G1, G2, G3,
G4
G4.
plus H1, G3, G4
H1, G3, G4.
plus
Yes.
H2, G2, G3.
H2, G2,
G3.
okay. So this becomes the transfer function for that signal flow graph. Okay. So any doubts? It is very simple. Only the thing is I have to identify the loops and the forward path in the right way. If I do that, just substituting the values of a T1, delta 1 and deltas and delta values into the equation, I will get a transfer function for any of the cases. Clear? Okay. So any doubts? Any doubt till here?
No, sir.
Okay. So can we, I want you to identify the loops only. So how much I have another 15 minutes. What I will do, we'll do a small exercise, and this time you will tell me the forward paths and the loops. Let me take a simple problem. One, two, three, 4, 5, 6. So numbering is very important. The nodes should be numbered properly. 5 and 6. And the gains, now I will be referring some of the terminologies. You have to catch them. So G3 is again, G4 is again, G5 is again, G6 is again, and represent the arrow marks, that is the flow of the signal. If you miss it, you cannot identify the loops. Okay. And from 4 to 3, there is a feedback, that is minus H1, and 2 to 5, it is forward paths, and this I will write as Z2. And from 5 to 2, 2 is a backward path or feedback, I call it as H2. Now I expect you to identify the forward paths. So already I have given the hint for identifying the forward paths. Can you tell me the forward paths? So let me write here, forward path. Yes, anyone identify the forward paths?
2 forward paths, sir.
Or
2 forward paths, T1 and T2.
okay, 2 forward paths are there. Hello.
Yes, sir.
Okay, tell me what is T1?
1 to 2, 2 to 3, 3 to 4, 5 to 6.
Okay. So in the sense, I will write, let me write it. I want other students also to engage in a class. Okay, I want a reciprocation. So 1, 2, 3, 4, 5, 6, right? So I'll write 1, 2, 3, 4, 5, 6. This is one forward path. Why? Because the signal is flowing from 1 to 2 is a G1, 2 to 3 is a G3, 3 to 4 is a G4, 4 to 5 is a G5, 5 to 6 is a G6. So this is one forward path, G1, G3, G4, G5, G6. Okay, which is the other forward path? Can anyone tell other than Vikas? Yes. Hello. Is it audible?
Yes, sir.
Yes, sir.
Okay. Can anyone tell the second forward path? I don't know why suddenly it got skipped when I asked other students. Means I don't know. Someone has removed my login. Okay. No idea. Okay. Vikas, can you tell what is T2?
Sir, 2 to 5.
2 to 5. It should be in a forward path, right? So 2 to 5 is only one loop. It cannot be the signal should go from 1. See, forward path means it should start from the input till the output. So input starts from 1, 2, then it will take a diversion from 2 to 5 and 5 to 6.
Yes,
So
sir.
this is the second forward path. Okay.
Yes, sir.
So it is G1, G2 and G6. Got it? And I have to write the product of all this. So T1 is equal to what? T1 is equal to G1, G3, G4, G5 and G6. And T2 is equal to G1, G2 and G6. These are the two forward paths. Now you have to identify what are the loops that are there. Identify the loops. So start from 2, just check whether there is a loop. So from 2 to 3 there is a signal, 3 to 4, 4 to 5 and 5 to 2. So it is one loop. And the second loop, 2 to 5, 5 to 2. This is the second loop. And the third loop is 3 to 4, 4 to 3. Okay. This is another loop. So in the sense there are 3 loops here. Now the second thing what I have to check here is, are there any other non-touching loops? 2 non-touching loops. So that I want you to identify and take this as an assignment, and I expect the answers in the next class. Clear?
Sir,
Yeah.
the loop 1 is in forward path, no, sir?
Loop 1 is,
In forward, no, sir. It should be
what
in
is that? What is
feedback.
that loop?
2 to 3, 3 to 4, and 4 to 5 to 2, sir.
It can be any loop. It doesn't mean whether it is first in first forward path or second forward path. It is immaterial. First we have to identify how many loops are there. Already we have identified how many forward paths are there, right? We have identified 2 forward paths. Now I have to identify how many loops are there, irrespective of the forward paths.
Yes.
Then we will see whether that loop is associated with which forward path or not. Okay.
Yes, sir.
So here your task is, I have already explained how to identify the loops and how to identify the 2 non-touching loops and also 3 non-touching loops. First identify which are the loops that are there in the signal flow graph, and identify whether there are 2 loops that are not touching to each other. and then you formulate the you substitute the gains in a formula, that is transfer function TF is summation of T K delta K divided by delta. So there I have to find what is delta and delta K. Okay, so this is how you have to take it. So kind of we'll go for the next session in the next class. And I want if you have any doubts, ask me now.